Dear students, welcome to this lesson on language of chemistry. Today, we are going to learn about balancing chemical equations. At the end of this lesson, you will be able to write balanced chemical equations. Let's consider the reaction between hydrogen and chlorine to form hydrogen chloride. The word equation for this reaction is hydrogen plus chlorine gives hydrogen chloride. We are going to use this word equation to write the chemical equation for the reaction. To do that, we must use symbols and formulae to represent the reactants and the products. Remember that hydrogen and chlorine are diatomic elements and have formulae H2 and Cl2 respectively. The formula of hydrogen chloride is HCl. Thus, we obtain the chemical equation H2 plus Cl2 gives HCl. Now, we must check whether this equation is balanced. To check whether the chemical equation is balanced, we need to count the number of atoms on each side of the arrow. To enable you to do that, we are going to use diagrams. We have used a sphere labeled H to represent a hydrogen atom and a sphere labeled Cl to represent a chlorine atom. Thus, a hydrogen molecule has been represented by two atoms of hydrogen joined together. Likewise, a chlorine molecule has been represented by two atoms of chlorine joined together. A hydrogen chloride molecule has been represented by an atom of hydrogen and an atom of chlorine joined together. Remember that a balanced equation has the same number of each type of atom on both sides of the arrow. So, let's count the number of atoms on each side of the arrow in this reaction. On the reactant side, there are two atoms of hydrogen, while on the product side, there is only one atom of hydrogen. Likewise, for chlorine, there are two atoms on the reactant side and one atom on the product side. Thus, H2 plus Cl2 gives HCl is an unbalanced equation. That is, it is not balanced because it does not have the same number of hydrogen atoms and chlorine atoms on both sides of the equation. In order to balance the equation, we must add one hydrogen atom and one chlorine atom on the product side. One very important thing you need to remember while balancing equations is that you always add atoms. Now, on the product side, the hydrogen atom and the chlorine atom are joined together to form HCl molecule. Therefore, you must add HCl molecules instead of separate hydrogen and Cl atoms to balance the equation. If we add one HCl molecule on the product side, we obtain 2 atoms of hydrogen and 2 atoms of chlorine. Now we have 2 hydrogen atoms on reactant side and 2 hydrogen atoms on product side. Also, we have 2 chlorine atoms on reactant side and 2 chlorine atoms on product side. Thus, the number of atoms of each element is balanced in the diagrams, but the chemical equation is still unbalanced. This is because we have 2 HCl molecules in the diagram, but in the chemical equation, we have only 1 HCl molecule. To obtain a balanced chemical equation, you should put a coefficient 2 in front of HCl to show that there are 2 molecules of HCl. Thus, H2 plus Cl2 gives 2HCl is a balanced chemical equation. Let's consider a second example. Hydrogen reacts with oxygen to form water. The word equation for the reaction is hydrogen plus oxygen gives water. The chemical equation for the reaction becomes H2 plus O2 gives H2O. Now, let's check whether the equation is balanced. As you can see, there are 2 atoms of hydrogen on the reactant side and 2 atoms of hydrogen on the product side. Therefore, the number of hydrogen atoms is balanced. However, there are 2 oxygen atoms on the reactant side and only 1 oxygen atom on the product side. The number of oxygen atoms is not balanced. Thus, H2 plus O2 gives H2O is an unbalanced chemical equation. To balance the equation, we need to increase the number of oxygen atoms on the product side. In order to do that, we should add 1 molecule of water on the product side. Remember, we cannot just add 1 oxygen atom because oxygen is joined to hydrogen on the product side. Now, if we count atoms, we see that the number of oxygen atoms is balanced, but the number of hydrogen atoms is no longer balanced. To balance the number of hydrogen atoms, we add 1 molecule of hydrogen on the reactant side. Now we have 4 atoms of hydrogen on both sides, and we have 2 atoms of oxygen on both sides. But if you forget to adjust the number of molecules in the chemical equation, the equation will still be unbalanced. To obtain the balanced chemical equation, we put the coefficient 2 in front of H2 on the reactant side. This shows that there are 2 molecules of hydrogen. Similarly, we add the coefficient 2 in front of H2O on the product side to show that there are 2 molecules of water. Remember, you should always use coefficients to balance an equation. You should never change the formulae and the symbols of the substances. We are now going to have a look at a third example, the reaction between nitrogen and hydrogen to form ammonia. The word equation for the reaction is nitrogen plus hydrogen gives ammonia. The formula of nitrogen is N2. That of hydrogen is H2, and the formula for ammonia is NH3. We will use a different method to balance the equation. Normally, when there is no coefficient in front of the formula, it means that there is one molecule. In this method, we will show this coefficient 1. As you can see, on the reactant side, there is one molecule of N2 represented by 2 blue spheres joined together. There is also one molecule of hydrogen represented by 2 white spheres joined together. On the product side, there is one molecule of ammonia, which consists of one atom of nitrogen bonded to 3 atoms of hydrogen. If you place the individual atoms on the balance as shown, you can see that neither the number of nitrogen atoms nor the number of hydrogen atoms is balanced. Note, on the balance, the atoms are not joined together. To balance the number of nitrogen atoms, we must multiply the molecule of ammonia by 2 on the product side. We do this by placing the coefficient 2 in front of NH3. Now you can see that the number of N atoms is balanced. But we have 2 hydrogen atoms on the reactant side and 6 hydrogen atoms on the product side. To increase the number of hydrogen atoms to 6 on the reactant side, we must multiply the H2 molecule by 3. This is done by placing the coefficient 3 in front of H2. Now, the number of atoms of hydrogen and nitrogen are balanced. The balance equation is N2 plus 3H2 gives 2NH3. You ignore the coefficient 1 in front of N2. Let's have a look at another example. The combustion of methane. Methane burns completely in air to form carbon dioxide and water. Note, during combustion, a substance reacts with oxygen. Thus, the word equation for the reaction is methane plus oxygen gives carbon dioxide plus water. Now we will write the chemical equation for this reaction. The formula of methane is CH4. The chemical equation becomes CH4 plus O2 gives CO2 plus H2O. If you count the number of atoms, you will see that the number of carbon atoms is balanced, while those of hydrogen and oxygen are not. Thus, the equation is unbalanced. We will first balance the number of hydrogen atoms. Since we have 4 hydrogen atoms on the reactant side, we place the coefficient 2 in front of H2O to multiply the molecule by 2. This gives us 4 hydrogen atoms on the product side. Thus, the number of hydrogen atoms is balanced, but the number of oxygen atoms is still unbalanced. To balance the number of oxygen atoms on the reactant side, we place the coefficient 2 in front of O2. This gives us 4 oxygen atoms on the reactant side. Now we have a balanced equation which is CH4 plus 2O2 gives CO2 plus 2H2O. Let's summarize the steps involved in writing a balanced chemical equation. In the first step, you write the word equation for the reaction. Then, you use symbols and formulae to represent the reactants and products in the word equation. In the next step, you count the number of atoms of each element to check if the equation is balanced. Then you add coefficients to balance the chemical equation. You can now practice balancing chemical equations from your textbook. This lesson was presented by Ms. Dukia, chemistry educator. Thank you for your attention.